I am Dr. Johnson Saurimuthu, Department of Mathematics. I am going to take central orbit, unit number 4, subject code EMT512A. Define central mass. If a force F acting on a particle is always directed towards the fixed point, then the fixed point F is called central mass, central orbit. The path traced by the particle under the action of force is called central orbit. O is called center of force. We can derive differential equation of central orbit with polar coordinates. A particle of mass m moves in a plane under the action of force directed towards the fixed point in the plane. Show that its angular momentum is constant and the differential equation of the path is d square u by d theta square plus u equal to f divided by h square u square, where u equal to 1 by r being the radius vector from the fixed point O, and theta is called vectorial angle. Let O be the fixed point, O by the pole, OX be the initial line. Let P, r, theta be the position of the particle at a time. F be the force which acts along pivot direction. We know that the acceleration component, radial and transverse directions are r double dot minus r theta dot square and 1 by r d by dt of r square theta dot of the acceleration components. There is no force along the transverse direction. Then 1 by r d by dt of r square theta dot equal to 0. d by dt of r square theta dot equal to 0. r square theta dot equal to h equal to angular momentum. Theta dot equal to h by r square. We can derive equation of motion. F equal to mass into acceleration. M into r double dot minus r theta dot square equal to minus mf. Minus f equal to r double dot minus r theta dot square, but u equal to 1 by r equal to 1 by u. dr by dt equal to minus 1 by u square du by dt. Minus 1 by u square du by d theta into d theta by dt. dr by dt equal to minus 1 by u square du by d theta into theta dot equal to minus 1 by u square du by d theta. We know that theta dot equal to h by r square. dr by dt equal to minus h du by d theta. Then again d square u by r dt square equal to minus h d by d theta of du by d theta into d theta by dt equal to minus h d square u by d theta square into theta dot minus d square r by d theta square minus h square u square d square u by d theta square. Substitute in one. Minus f equal to minus h square u square d square u by d theta square minus r h square by r power 4. F equal to h square u square d square u by d theta square plus h square u cube. F equal to h square u square of d square u by d theta square plus u. Then d square u by d theta square plus u equal to f divided by h square u square. This is the differential equation of central orbit with polar coordinates. We can derive PR equation central orbit. We know that PR equation 1 by p square equal to 1 by r square plus 1 by r power 4 of dr by d theta whole square. But u equal to 1 by r equal to 1 by u. dr by d theta equal to minus 1 by u square du by d theta. Substitute in equation 1, 1 by p square equal to 1 by r square plus 1 by r power 4 into r power 4 of du by d theta whole square. 1 by p square equal to u square plus du by d theta whole square. P power minus 2 u square plus du by d theta whole square. differentiating with respect to r, minus 2 by p cube dp by dr equal to 2u du by dr plus d2 du by d theta into d by dr of du by d theta minus 1 by p cube dp by dr equal to u du by dr plus du by d theta into d divided by d theta of du by d theta into d theta by dr u du by dr plus du by dr into d square u by d theta square. Therefore, du by dr equal to u plus d square u by d theta square. We know that d square u by d theta square plus u equal to f by h square u square. Du by dr of f divided by h square u square. But u equal to 1 by r, du by dr equal to minus 1 by r square. Minus 1 by r square dp by dr equal to minus 1 by r square of f divided by h square u square. Therefore, f equal to h square by p square p cube dp by dr, which is the PR equation of central orbit. Problem. Show that the velocity at any point p of r comma theta is a central orbit is given by v equal to h by p, where the constant angular momentum. Prove that v square equal to h square u square of plus du by d theta whole square. We know that the radial velocity components along the radial and transverse direction r dot and r theta dot. V square equal to r dot square plus r theta dot square, r dot square plus r square theta dot square, r dot square plus r square h square divided by r power 4. R dot equal to dr by d theta whole square plus h square by r square, dr by d theta into d theta by dt whole square plus h by r square, dr by d theta whole square h square by r power 4 plus h square by r square, dr by d theta whole square into h square by r power 4 plus h square by r square, h square of 1 by r square plus 1 by r power 4 of dr by d theta the whole square, h square of 1 by r square plus 1 by r power 4 du by d theta whole square. Then v square equal to h square of u square plus du by d theta the whole square. A particle is a direction of an equiangular spiral r equal to a e power theta cot alpha under the action of the force under the pole. Find the law of force. We know that differential equation of central orbit d square u by d theta square plus u equal to f divided by h square u square, given r equal to a e power theta cot alpha, r equal to 1 by u a e power theta cot alpha minus log u equal to log a plus theta cot alpha. Differentiating with respect to theta, minus 1 by u du by d theta equal to cot alpha, du by d theta equal to minus u cot alpha. Again differentiating with respect to theta, d square u by d theta square equal to minus cot alpha du by d theta, d square u by d theta square equal to u cot square alpha. Substitute 1, u cot square alpha plus u equal to f divided by h square u square, u of 1 plus cot square alpha equal to f divided by h square u square, u 1 plus cot square alpha equal to cosecant square alpha, u cosecant square alpha equal to f divided by h square u square, h square u cube cosecant alpha equal to f equal to k u cube, where k equal to h cosecant square alpha, f is proportional to 1 by r cube.